We now discuss the solution of a problem from the section Trigonometry. The question is based on the inverse trigonometric functions. This question has appeared in the joint entrance examination main held on 26th June 2022 in the first shift. The given question is, let f of x is equal to 2 cos inverse x plus 4 cot inverse x minus 3x square minus 2x plus 10, where x belongs to the closed interval minus 1 to plus 1. If the closed interval a comma b is the range of the function f, then 4a minus b is equal to. We are given 4 options. Option A 11, option B 11 minus pi, option C 11 plus pi, option D 15 minus pi. We have a function f of x is equal to 2 cos inverse x plus 4 cot inverse x minus 3x square minus 2x plus 10, where x belongs to the closed and bounded interval minus 1 to plus 1. If the closed and bounded interval a comma b is the range of this given function, required to find the value of 4a minus b. That is our given question. We now discuss the solution of the problem in detail. We have the function f of x is equal to 2 cos inverse x plus 4 cot inverse x minus 3x square minus 2x plus 10, where x belongs to the closed and bounded interval minus 1 to plus 1. Now, we discuss the increasing decreasing nature of this function. For that, we consider its derivative, differentiating f of x with respect to x. We get f prime x is equal to 2 into derivative of cos inverse x is minus 1 by under the square root of 1 minus x square plus 4 into derivative of cot inverse x is minus 1 by 1 plus x square minus derivative of 3x square is 6x, derivative of minus 2x is minus 2, derivative of 10, the constant is 0. Now we take minus 2 common, that is equal to minus 2 into, in brackets, 1 by under the square root of 1 minus x square plus 2 by 1 plus x square plus 3x plus 1. Now, we have to see whether this f prime x is greater than 0 or less than 0 in this interval. For that, we take a convenient point in this interval, x belongs to minus 1 to plus 1, namely 0, and test it. Test the nature of f prime x at x is equal to 0, and that is, if the sign of f prime 0 will be the sign of f prime x for all x belongs to the interval, closed interval minus 1 to plus 1. Notice that convenient point what we have considered is 0, f prime 0. So if you put f prime 0, so the function that is in the bracket is positive and minus 2 times will be negative. And the same character, namely less than 0, will be applicable for f prime x for all x belongs to the closed interval minus 1 to plus 1. This implies f prime x is a negative for all x belongs to the closed interval minus 1 to plus 1. So this implies f of x is a strictly decreasing function in the closed interval minus 1 to plus 1. That is, x1, x2 belongs to the interval minus 1 to plus 1. x1 less than x2 will imply f of x1 is greater than f of x2 because it is strictly decreasing. This implies f of x2 is strictly less than f of x1. When x1 less than x2, f of x2 is strictly less than f of x1. Now, you can apply. So, what happens in minus 1 to plus 1? Therefore, f of 1 less than or equal to f of x less than or equal to f of minus 1. Why? Because 1 is x2, let us say, x1 is minus 1. So, if you apply, then it will be f of 1 less than f of minus 1. But it takes the values, all values, because it is a continuous function, f of 1 less than or equal to f of x less than or equal to f of minus 1 for all x belongs to minus 1 to plus 1. Because it is strictly decreasing, f of 1 will be minimum and f of minus 1 will be maximum. So, thus we got f of 1 less than or equal to f of x less than or equal to f of minus 1 for all x belongs to the closed and bounded interval minus 1 to plus 1. We continue in the next slide. So that's the given problem, and what we have is the inequality 1, what we have written, f of 1 less than or equal to f of x less than or equal to f of minus 1 for all x belongs to the closed and bounded interval minus 1 to plus 1. Let us see what is f of 1. F of 1 is 2 cos inverse 1 plus 4 cot inverse 1 minus 3 minus 2 plus 10. 2 cos inverse 1 is 0. Cot inverse 1 is pi by 4. So 2 into 0 plus 4 into pi by 4 minus 3 minus 2 plus 10. This will be pi plus 5. And let's see what is f of minus 1. F of minus 1 is 2 cos inverse minus 1, 4 cot inverse minus 1, minus 3 into minus 1 whole square, minus 2 into minus 1 plus 10. Now, cos inverse of minus 1 is pi, 2 pi. And cot inverse of minus 1 is 3 pi by 4. So, 2 pi plus 4 times 3 pi by 4 minus 3 plus 2 plus 10. So, it is 2 pi plus 3 pi, that is 5 pi plus 9. So, f of 1 value is pi plus 5. F of minus 1 is 5 pi plus 9. From the inequality 1, what we get is f of 1 pi plus 5 is less than or equal to f of x less than or equal to f of minus 1 5 pi plus 9 for all x belongs to the closed and bounded interval minus 1 to plus 1. That means f of x belongs to the closed and bounded interval pi plus 5 comma 5 pi plus 9 for all x belongs to minus 1 to plus 1. This will imply the range of f is pi plus the closed and bounded interval pi plus 5 to 5 pi plus 9. It is given in the question. The range is the closed and bounded interval a to b, then required to find 4a minus b. So, the closed and bounded interval pi plus 5 comma 5 pi plus 9 is equal to the closed and bounded interval a comma b, then a is equal to pi plus 5, b is equal to 5 pi plus 9. Now we find 4a minus b. 4a minus b is equal to 4 times pi plus 5 minus in brackets 5 pi plus 9. Simplifying, 4 pi minus 5 pi is minus pi. 4 5s are 20 minus 9 11. 11 minus pi. 4a minus b is 11 minus pi. Let's look at our options. Our answer 4a minus b is equal to 11 minus pi appears against option B. Therefore, the answer for this question is option B. That is the detailed discussion of the solution of the problem from the trigonometry on inverse trigonometric functions. And it is definitely moderate. It's a moderately difficult question, but many students can very easily do this kind of problems. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.